Kailey's a fourth-year Bachelor of Science Kinesiology student at Laurentian University. She has worked with CROSH since 2024, including 2 summers as an NSERC-funded undergraduate student research assistant, or USRA. Focusing on preventative health research, she is currently completing her undergraduate thesis under the supervision of myself and Dr. Alison Godwin. And so her title here is Determining Changes in Vibration Transmissibility to the Seat and Head After Seat Adjustment Training. Whenever you're ready, Kailey.
Perfect. Can you see the screen okay this time?
Yes, thank you.
Okay, awesome. All right, so I'm going to be doing my presentation on my 4th-year thesis, undergrad thesis that I'm working on right now. And it's on determining changes in vibration transmissibility to the seat and head after seat adjustment training. And like Dr. Goggins said, I'm supervised by herself and Dr. Alison Godwin. Okay, so to start, I'm going to review some vibration basics so that we're all on the same page for this presentation. So whole body vibration is measured across 3 different axes. So we have this X direction here, and that's going to be the forward and backward direction. Then we have the Y, which is going to be like that sideways or lateral direction. And then we have the Z axis, and that's going to be the up or down and the vertical direction. And this is the one that we're going to be most concerned about with whole body vibration. So whole body vibration describes the vibration that typically travels through the body, and it comes in contact usually from the platform. So here we could have it in the seat. We can also have it through hand vibration tools like a steering wheel. And then we have seat to head transmissibility. And this is a measurement of whole body vibration and focuses on the effects from the seat all the way to the head. So to understand the effects of vibration on the body, it's important to understand how vibration actually travels through the body. So in physics, this may be a long time for some of you, you may remember the concept of constructive interference. So basically what happens is when we have 2 waves that are the same frequency or the same, we can even say amplitude here, like this one right here and this one right here, if they come in contact, so if they meet and match, they will actually add together if they're the same frequency. And this will create a much bigger wave here. So that concept applies to our body tissues. So we have tissues like muscles, joints, even some spinal structures. And when we have the natural frequency, well, they all have natural frequencies that they tend to move at. But when we have like a natural frequency, let's say right here in the spine, when the external vibration enters from the seat, so we're going to have this like blue wave right here is going to be that external vibration. When we have that external vibration that runs into or comes in contact with the natural frequency of the spine, and they are the same frequency, what we're going to have is that we're going to have an amplification. So we're going to have an increase of movement, which could likely lead to tissue displacement, and that's how we can have injuries. So whole body vibration has been linked to an increase of musculoskeletal disorders or MSDs. And this makes sense after what we have looked at just with the resonant frequencies there. So the most common complaint that we have is low back pain, and that's most commonly reported in mobile equipment operators. And then we have other common complaints of MSDs in the neck, the shoulders, the back, knees, wrists, and hands. So many workplaces do not provide seat adjustment training, except in some office-based settings where this training has been shown to be effective to reduce MSDs. And given that posture does have a significant influence on vibration transmission through the body, training mobile equipment operators to properly adjust their seats may provide an effective and accessible way to reduce whole body vibration exposure. Without proper training, operators may be subjecting themselves to greater vibration exposure than necessary. So CROSH developed a seat adjustment training program under the supervision of Dr. Kailey Goggins, and you may have seen a presentation similar to that last year. What they did with this program is they tested the program at mine sites with operators. They were handed a brochure, so something like this, And then they watched a seat adjustment training video, which explained the brochure, and then got to practice their seat adjustment techniques on real equipment. So when this program was evaluated, researchers found that participants showed an increase in both knowledge and confidence after training, which suggests that seat adjustment training can improve what workers know and how confident they feel about adjusting their seats. So research, though, is missing in the area of seat adjustment and its effects on vibration transmission. So that's why we decided to determine whether there is a measurable change in vibration transmissibility before versus after completion of a seat adjustment training program by looking at the seat effective amplitude value. So that's the seat value, and it looks at the compares the platform and seat transmissibility. And then, so it's here, we're kind of looking more at seat suspension. And then we also have the seat to head transmissibility, and that's going to be looking at the transmissibility from the seat all the way to the head. So for the setup for this experiment, we had an air suspension seat mounted to this rotopod vibration platform here. And then we had a steering wheel and a pedal setup. And then we had participants play a truck and logistics simulator with the steering wheel again and the pedals. To collect the data, what we did is we used triaxial accelerometers, which were used to measure vibration. And we had one mounted to the platform. So it's like under that little duct tape. And then we had it on the seat, it's in that capsule. And then on the head here, and the accelerometer is actually behind that little adjustable piece. So this was the adjustable head piece that the participants wore. And then for the health risk profiles, what we did is we used a low, medium, and high health risk profile based on the ISO 2631 standards. And this is based on the average exposure over an 8-hour work shift. So it's not, the participants in our study were exposed to 5 minutes of it. But this is actually, the health risk profiles are based over an 8-hour average period. And these profiles are also based off of the ones that we use for this study that we converted into the rotopod are based off of real field data on different pieces of equipment. And then the signals were coded into this rotopod platform. So now for what actually happened, we had participants come to the lab. They completed this body composition analysis, a demographic questionnaire, and we attached all the accelerometers. And then they adjusted their seat to comfort without direction, and were exposed to 3 5-minute vibration profiles, so that low, medium, and high, in a randomized order. Now the training part. So before the training actually happened, we did have participants complete a pre-training questionnaire, and that assessed knowledge, behaviors, self-efficacy. And then they were handed a brochure, so this one right here. And they also watched a seat adjustment training video, which matches the brochure and explains it. And I just want to highlight that steps 1 to 3 here, you might not be able to see, but steps 1 is seat suspension, step 2 is seat height, and step 3 is backrest angle. These are very significant factors for the seat adjustment. And then after training, so participants readjusted their seat using what they learned, and then they also were holding that brochure in their hand. So they also were using that brochure to help them out, but they still had no direction from the researcher. And then they repeated the same 3 vibration exposures, and then completed the training, post-training questionnaire that looked at the knowledge, self-efficacy, and feedback. Okay, moving on to the results. So we had 30 participants participate and aged 18 to 46. Most were in between the ages of 18 to 22. There were 19 females, 10 males, and 1 participant who preferred not to identify. And most of the participants had not previously completed any seat adjustment training before. So before getting into, these are going to be the vibration results I'm going to be explaining next. Before we get into them, I just want to preface that I am still in the middle of analyzing the data for my thesis. So this is very preliminary results. And at this time, we actually don't know if the training worked or not. So we're just going to kind of give you a little bit of overlook at what we're seeing with the data right now, just so you're not left leaving the presentation of, did it work, did it not? We're not sure yet. Hopefully next year we'll have that information for the next presentation. Okay, so before getting into the results, I'm just going to explain the graph a little bit just so it makes sense. So each line, actually first we're looking at the z-axis here because I said that the z-axis is dominant for vibration, so that's the one that we're going to look at, which is that up and down. So we have the light gray line here. That's going to be the pre-exposure. And then we have the dark gray line, and that's the post. And this is averaged across all 30 participants. And then we have the health risk profile, so low, medium, and high. And then this is for the seat, and this is for the seat to head transmissibility. So when we look at these averages, the pre and post training values are very similar at both the seat and the head. So at first glance, this might suggest, the training had no effect. However, when we take an average, we're not able to look at the individual differences. So it's not taking into account body size. It's not taking into account the seat adjustments that were done. It's not taking into account how participants interpreted the training. So we can't actually see where the improvements are for some participants and where the worsening is for others. So to better understand what was actually happening, we decided to look at the time series data, which basically allows us to see how much vibration is being transmitted at a specific frequency. So these are for individual participants, these next graphs. Again, we're looking at, right here, we're looking at the seat, but we're looking at the vertical axis, and this is a low vibration profile. And right here, we can see that there was a reduction in vibration transmission. So the pre for this one is going to be in the black line, and the post is going to be in that light gray. And because the pre looks to be much higher than the post, it shows that there was a reduction post-training for this participant. So we can, based on that, it looks like, yeah, the training did work for this participant and for this profile. But then we have a whole other participant here. This is a high profile though, but we're seeing that post-training, it might be a little bit harder to tell on this one, but post-training, it does look like it's higher. So for this one, it's looking like it's saying like the training did not work for this participant and for this profile. And then we're seeing the same thing with the seat to head transmissibility. So again, we're seeing that this one, it looks like it did work. We have quite a large difference between pre and post here. And post is lower, which is a good thing. And then same thing again here, we're seeing that it looks like it did not work because our post values seem to be higher at specific frequencies. And then we have something else that's really interesting that we're seeing. So not only are we seeing those differences between participants that, it's working for some, it's not working for others. But in this example here, I'm just showing the head. But this is the same participant. So different profiles, but same participant. And on the left, we have a high vibration profile. And it shows that the training did work. So there's lots of little peaks here, but you can see again, the pre-values look to be higher than the post. And then for the low profile though, the post looks to be much higher than the pre-values. So again, we're seeing differences, a lot of variability. We're seeing differences between participants. We're seeing differences between profiles. So there's a lot going on here. So basically our next steps are to isolate these differences and see, is this difference between this peak right here and let's say this peak right here, is that a significant difference? Because visually it looks like yes, but statistically we don't know. So we're trying to basically isolate these differences and, use a statistical model to determine if there is a difference and determine if it's a limitation of the training or if it's a limitation of the seat, and even try to determine why. So we're possibly going to look at body composition to see if there's any interpretations to be made there as well. And then remembering that we also had participants complete questionnaires. So one of the things that we assessed was knowledge, and overall knowledge scores did increase after training from an average pre-training average score of 76% and an increased post-training to an average of 92%. And then with behaviors, the most consistent behavior reported among participants was adjusting their seat when they entered a vehicle, with all participants reporting that they do it at least sometimes. And then self-efficacy, we're also seeing an increase post-training. So the average pre-training confidence score was a neutral, and then the average post-training score was it increased to they're agreeing with it. So what could this mean? So to explain why we think there is such variability in the results, specifically with the vibration data, we do have a few ideas. So many participants did struggle with adjusting the seat suspension, the seat height, and the backrest angle. So in this seat suspension, which was it was tied into the seat height. So this button right here basically filled the air bladder with air. And so if you increased it, it would go up, and if you decreased it, it would release the air. But participants were more concerned about the seat height, and they didn't really take into account that like it also has a role to play in seat suspension. And then we also have this damper setting right here, but it wasn't explicitly covered in the training. So participants generally they did not know how to use it. And then another factor is that there was a handful of participants that followed the training, step by step. They looked from step 1 all the way to step 8, and they did it exactly how it said. We only had a handful of those ones who did it like that. And then some adjusted it in random orders. So they pick and chose which ones they wanted to adjust first. There was a few that actually did not make any adjustments at all from pre to post. And less than half of the participants actively tested the damper by actually bouncing on the seat to see like what is the seat suspension doing. So it just goes to show that even though we saw an increase in knowledge and confidence after the training was completed, this does not necessarily translate into behaviors. And then although this sample consisted of mostly students, this is not necessarily a limitation because it does show that it may accurately represent new or inexperienced operators, which is most likely the population that would receive this type of training during onboarding. And so to conclude, if this training proves to be not consistently effective, this suggests that a general training approach may not be the most appropriate. On the research end, we would tailor the training to specific seats and focus on refining the areas people tend to struggle with and retest it. In general, future trainings may need to be tailored to specific seat models, control layouts, suspension mechanisms, all of that, which may require greater involvement from manufacturers. But notably, most manufacturers don't provide or provide limited guidance on how to actually adjust a seat to fit the operator. So this training still can be used because it does outline the general way to adjust a seat, meaning people on the health and safety committee at your workplace who is trained in ergonomics could still use this as guidance, but tailor it to the specific seats that your operators are using. So for example, if the seat has a damper setting, you could probably add that section in on seat suspension and the damper setting in the seat adjustment training that you do. On the other hand, if the seat adjustment training shows it may be effective in reducing vibration transmissibility, this suggests that it may need refinement, particularly in seat suspension. But otherwise, we could start looking at methods of deployment like training sessions with a goal to bring attention to this training in hopes of reducing vibration transmitted through the operator, which may ultimately help reduce musculoskeletal disorders, improve quality of life for workers, and reduce lost time claims in the workplace. So I do have a few acknowledgements I'd like to make. So I would like to thank I Am Gold for funding and supporting this work. I'd like to send a huge thank you to all the participants of the study because they contributed their time and effort. I want to give a huge thank you to the CROSH lab technicians, Dawson and Margaret. They helped tremendously throughout this entire process, whether it was experimental setup, data collection, data processing, all the little details in between. They were a huge help. I'd like to thank Courtney for her statistical analysis help. And then, of course, Dr. Kailey Goggins for supervising me and providing her expert guidance. And then those are references, and I'll open it up to any questions if anyone has any.
Awesome. Thank you, Kailey. You do have some questions. So we're going to start with what factors are the spine's natural vibration frequency based on? So up front when you did some background stuff there.
Sorry, I feel like I didn't hear your question. Could you repeat it?
Yeah, that's okay.
No worries.
What factors are the spine's natural vibration frequency based on?
Okay, interesting. So maybe I'll go back. Where is the slide? Okay, I'll go here. So I'm assuming we're talking about this right here with the natural vibration or the natural frequency of the spine. So
Mhm.
they're very, I think research is still trying to get there at determining what the actual natural like resonant frequencies are within the body in general. But in terms of factors, I'm not 100% sure on if there's necessarily factors that determine it. Again, I feel like research is lacking in this area because they don't even have, it's a very large range of frequencies to begin with, of like varying from this many hertz to like this many hertz. So I'm not quite sure. I don't know. Dr. Goggins, do you have anything to add there? Maybe you have more knowledge in that.
So yeah, I'll help you with this one. So this one, so
Yeah.
yes, yeah, I'll help you with this one. That's no problem. So there's differences in the lower spine here, and so we'll see in the lumbar spine has a difference than the pelvis. And don't overthink this answer, Kaylee. You know this, but you know that it's based on the physiology and the biomechanics of that tissue, and so it's based on the density of the like how much bone, how much muscular tissue, what's actually there, and so to test these areas, typically we're putting an accelerometer on the location, and we are running it through a vibration kind of profile. A lot of this is done on animal models, so a lot of this is actually tested with animals. For instance, like rat tails are used for finger resonance and things like that. And so we don't normally do much specific, you are correct, with the human being exposed. There's cadaver experiments and stuff like that, but we don't normally expose fully live tissue for all of those things. That's okay. So we have another question. So I'll ask this one. Hello, thank you for your presentation. Are the technical specifications and the adjustment video available? If so, where can we access them?
Do you want me to answer this one?
Go ahead.
Okay. Right now, we are still in the testing phases of the video and the training. So, in terms of are they publicly available right now, I don't believe we have them posted on the website. We're hoping to have these available though in the future so that they still can serve as a general recommendation. I'm not sure when that would be. I don't know. Again, Dr. Goggins, this might be more of a question
Okay.
for you as well.
Yeah, that's okay. So I'll take it. So we do not have, Kaylee's correct. We do not have these readily available just yet, mostly because we're testing to make sure that they're working. And so once we ensure that these are working, we do understand for both experiments, this one and a master's student previously, that the knowledge and the confidence to do the seat adjustment is working. And so we're just through Kaylee's experiment, once we figure out if there is a problem with the suspension, like she suggested, then we will eventually get this hosted on some form of platform. Not sure exactly how we're going to implement it, but that is the idea. So Anne has a comment here for Kaylee. Just my thought is, did you take a picture of the person in the seat? How was their form? That may affect the results. Did their lumbar line up, shoulder support, etc.? Did it fit in the good ones and not align in the not so good results?
Yeah, this is such a good question and comment. I really like this one. So we did actually take lateral photographs before the training and then after the training. And we haven't looked at any of those pictures at this point right now, just because, like I said, I'm still in the early process of doing the data analysis. But posture does impact how vibration is transmitted. So even like the way your head sits and like if it's turned, like all of that stuff affects it. The pelvis, if it's tilted forward versus backwards, like all those things affect it. And we are aware, like even knee angle, leg extension, arm extension, like everything can affect how vibration is transmitted, which is why we decided to take a participant or a photograph of each participant pre-training versus after training. But yeah, it will be really interesting to see what kind of comes out of that. I think we'll use it more so if we have a lot of outlier data or like just data that's very, very different from participant to participant to kind of compare these differences to see if maybe it was the way that they were sitting in the seat or different things like that. So I'm super curious to look at the body composition data and like the photographs and look at the posture and stuff as well. But yeah, it's a really good comment.